Hello friends, in this video we are going to talk about two more types of modulated fiber optic sensor, and they are phase modulated fiber optic sensor and polarization modulated fiber optic sensor, in which phase and polarization of the light signal is get changed and then it is compared with the reference signal to obtain the required result. Let's discuss these two types of sensors in detail. So let's begin with the topic. In this video, we are going to talk about another two types of fiber optic sensors, and they are phase modulated fiber optic sensor and polarization modulated fiber optic sensor. In our previous video, we talked about how the fiber optic sensor are get classified and what is the function of fiber optic sensor. Just have a quick recall of that. The fiber optic sensor basically acts as a transducer. That means they convert the pressure, temperature, stress, strain or any other quantity into a corresponding optical radiations. For that, the various modulation techniques can be used, and the modulation techniques are intensity modulation, phase modulation, wavelength modulation and polarization modulation. Based on which technique we are going to use, there are different types of fiber optic sensor, because these are the four factors by which the light is get characterized. So whenever there is a change in the external environment, so that change causes change in any one of the parameter. Intensity is nothing but amplitude and wavelength is nothing but a frequency. In short, the intensity modulated are simple in construction and easy to handle, in which intensity of the signal is get vary. In case of phase modulated fiber optic sensor, they are difficult to handle and complex in design, but at the same time they provides a very high sensitivity and high resolution. And in case of phase modulated fiber optic sensor, phase of the signal is get changed. Moving to the next, wavelength modulated fiber optic sensor causes change in the frequency, that is nothing but the wavelength of the signal. And the last one, polarization modulated fiber optic sensor, in which polarization of the signal is get compared. That means polarization of the transmitted signal and polarization of the received signal. If there is any change, then that causes variation in the radiated output signal. Now let's talk in more detail about a phase modulated fiber optic sensor. The phase modulated fiber optic sensor are basically used in interferometer. This sensor provides a very high sensitivity and high resolution, even though they are very much complicated in design and they are very difficult to handle. In case of interferometer, the light beam is get divided into two parts, or we can say the light is get split into two beam. One beam is exposed to the quantity which is under measurement, and that beam undergoes a change in the phase, whereas the other beam is used as a reference beam. For not changing the phase of the reference beam, it kept isolated from the external environment. So when these two beams get combined with each other, or we can say when they interfere with each other, then there will be a change in the phase, because the first beam that we expose to the quantity which is under measurement. So when the quantity, for example, if we want to measure a temperature, so the first beam is exposed to the temperature. So therefore, if there is any variations in the temperature, then that variation causes change in the phase of the exposed light beam. Now, when we compare the exposed light beam with the reference light beam, definitely there will be a difference between the phase of these two signals, and that difference causes change in the output. That means change in the optical radiations at the output. So this is how basically the phase modulated fiber optic sensor work. Match Zehnder and grating interferometer are the most commonly used interferometer in case of fiber optic communication system. The phase modulated fiber optic sensor find majority of the application in the field of electronics, science, engineering and communication system. So when we compare the phase modulated fiber optic sensor with the intensity modulated fiber optic sensor, then the one major difference is that the phase modulated fiber optic sensor, they provide a very high sensitivity and high resolution, and therefore The application in which the sensitivity and resolution are the major requirement, so in those applications, these sensor plays an important role. Now let's talk more about a polarization modulated fiber optic sensor. We know that the fiber optic cable is made up of glass or a plastic, and they have a refractive index. The refractive index of core and refractive index of cladding both are different. Even we know that when the light signal travels from one medium to another medium, the refractive index is get changed. Even inside the fiber optic cable, when the light signal travels from core to cladding and from cladding to core, the refractive index is get changed. So this principle is basically used here in case. When we apply stress or strain on the fiber optic cable, then in that case, there will be a change in the refractive index of the fiber optic cable. This principle is called as photoelastic effect. So whenever we apply stress or strain, or we can say whenever we apply a pressure on the optical fiber cable, then its refractive index is get changed. Now, when we deploy a optical fiber cable in the external environment, then there may be a possibility that the direction from which the stress or strain applied on the fiber optic cable may be a different. So, there are chances that the different changes in the refractive index of the fiber optic cable occurs in different direction. Now, when the light travels through such type of fiber optic cable, so definitely there are certain losses, and as there is a change in the refractive index, the output will get varied. There are various effects which causes a change in the polarization of the fiber optic cable. Application of stress and strain changes the polarization. That means there is a difference in the polarization state of the optical fiber signal. Faraday rotation, magnetic field, and other parameter also causes or also have an influence on a light signal. That means they also changes the polarization state of the signal. We can twist the fiber. So when we twist the fiber, then also there will be a change in the polarization of the signal. So in case of polarization modulated fiber optic sensor, basically the polarization of the transmitted light and polarization of the reflected or received light are get compared with each other, and if there is any variation, then that variation results into variation in the optical radiations at the output. Various types of mechanisms can be used which causes change in the polarization of the signal, such as magnetic effect, because the magnetic effect results into a Faraday rotation, and Faraday rotation have an influence on the polarization state of the light. So even if the polarization, or we can say even if the optical fiber is placed in a magnetic field, then that causes a variation in the polarization of the optical fiber signal. So this is what about a polarization modulated fiber optic sensor and phase modulated fiber optic sensor. In short, let's summarize phase modulated fiber optic sensor, in which there will be a change in the phase of the signal, and in case of polarization modulated fiber optic sensor, there will be a change in state of polarization of the optical signal. In phase modulated, the phase of the reference signal is get compared with the phase of the signal which is exposed to a quantity, whereas in case of polarization modulated signal, the transmitted light polarization state and the reflected or received light polarization state are get compared and results into the variation in the optical signal at the output. So this is what about these two types of fiber optic sensors. So I hope you understand this topic. So thank you very much for watching this video.